Good morning, students. So today we will discuss about elastic collision in one dimension. This topic is from chapter Work, Energy and Power. So in this topic we will prove that in one dimension head-on elastic collision, if two bodies having same mass, then after collision they exchange their velocities. So let's try to prove this. So let A and B are two bodies who having same mass. Let A body is moving with velocity u1 and another body B it is moving with velocity u2. Since u1 is greater than u2, so after some time they collide and then they separate. So let now A body it is moving with v1 velocity now after collision, and likewise another body B it is moving with final velocity v2 here, and let m be the mass of each body, same mass. Now always remember that in elastic collision in one dimension or in simple elastic collision, definition indicates that kinetic energy as well as momentum in elastic collision is conserved. That is, kinetic energy remains constant after collision and linear momentum of these two bodies also remains constant after collision here. So remember the definition of elastic collision. So in elastic collision, kinetic energy as well as momentum remains constant. So going to use this concept here. So according to law of conservation of momentum. So according to this law of conservation of momentum, total momentum before collision of these two bodies, that is mu1 plus mu2, equal to total momentum of A and B body after collision mv1 plus mv2, can be written, rearrange it, that is m can be taken common u1 minus v1, this mv1 can be taken this left hand side, and likewise mu2 can be shifted to right hand side, that is m v2 minus u2. Let first equation, likewise according to law of conservation of kinetic energy. So kinetic energy again remains constant. It means total kinetic energy of A and B body before collision. So before collision we have a formula again, half m u1 square plus half m u2 square, always equal to after collision, that is half m v1 square plus half m v2 square. Again this can be modified, that is half m can be taken common and rest is u1 square minus v1 square. This term half m v1 square can be shifted to this left hand side like this. This another term half m u2 square can be shifted to right hand side and half m can be taken common, that is b2 square minus u2 square. This can be further written, that is, now see half m constant cancelled by this half m, likewise this m cancelled by this m from first equation, or we can say that u1 minus v1 u1 plus v1, that is a square minus b square in terms of mathematical formula, like this way, v2 square minus u2 square can be written v2 minus u2 and rest is v2 plus u2. Let's second equation. Now divide first equation by second. So by dividing equation 1 and equation 2, divide these two equations, that is we get, so if we divide the second with the first, u1 minus v1 cancelled by this u1 minus v1, and here we left u1 plus v1. So we directly writing u1 plus v1 here, and this side v2 minus u2 cancel by this v2 minus u2. Rest is v2 plus u2 as it. Again it can be written, rearrange it, that is v1 equal to now, so v2 plus u2 minus u1. Let third equation. Again, if we substitute the values of this v1 in this first equation, we can calculate the value of another quantity v2 here. So now by substituting the value of v1 from equation third in equation 1, we get, substitute here, it means u1 minus v1. So instead of this v1, I write this, that is v2 plus u2 minus u1. Other is v2 minus u2, so v2 minus u2 as it can be written, that is u1 minus v2 minus u2 plus u1 equal to v2 minus u2. See here now, here minus u2, here also minus u2, these are cancelled to each other. Rest can be written, that is u1 plus u1, it becomes 2u1, so 2u1 and this v2 this side, right hand side, it becomes plus here, so v2 plus b2 here this side, it becomes 2b2, 2 cancel by 2. This implies that u1 equal to v2. It means after collision, whatever the velocity of first body, that will become velocity of second node, that is b2 becomes u1. It means they exchange their velocities. Likewise, if we substitute this value of u1 equal to v2 in third equation, we can also find another relation, that is by putting the value of u1 equal to v2 in third equation. So we get now, so writing here v1 equal to now this v2 plus u2 minus u1. Now instead of u1, substitute this value of v2, so that is we get now v1 equal to now, that is b2 plus u2 minus b2. This v2 cancel by this minus b2, and here we get v1 equal to now u2. It means whatever the initial velocity of second body, that will becomes the final velocity of first body. It means these two bodies who having masses same, that is m masses, equal masses, then after head-on elastic collision in one dimension, they exchange their velocities. So just revise this topic, a simple topic, and if facing difficulty, then concern with me. So revise this topic, important topic.